Hello, everybody. In this video, I'm going to solve the question 41C. This is a calculus question of the course Maths1151 at UNSW. This is another interesting question to solve. It is the solution or the proof is a bit tricky. So we would like to show for each n a positive integer, and we would like to prove this inequality. Now, in this question from part B, we have this inequality, and we are going to use this inequality and drive from this inequality to this inequality. And the k here is from 1 to 3n. And the hint is given in this question, consider the k for the case 1, 2, 3 up to the n for part B. Now let's write it down. Let's write it down what we have. So the first one, k is equal to 1, we have 1 plus 1, 1, and then we have 1 plus 1, 1, and 2. So this will be 2 and 2 squared. It says that 2 is between, E is between 2 to the 2 and 4. And now for k is equal to 2, we have this case. For k is equal to 3, we have this case. I'm just writing down and trying to understand what to do, right? Because I'm supposed to use this inequality, and I'm supposed to look at everything with the k is equal to 1 to the n. Now it says e to the n here. This is the equation inequality that I want to prove, e to the n. Now I'm looking at these inequalities, and I'm thinking that how can I find e to the n? Because if I multiply e to the n on both sides, I will have e to the n here. So I have already e's here. And I have n items here. I can multiply side by side all of these inequalities. What I'm saying is that I multiply all of those, I multiply all of those, it will be always smaller than in that case, and then multiply all of those, that will be still smaller. But in that case, I will be able to get some property, some expression, including the e to the n. So that's what I want. If I multiply and then have a look, and then can have a look whether I can find a pattern, if I can simplify it, right? This is how we work. I didn't know how to prove this from the beginning, but step by step, work it out. Okay. Again, as I said, I'm multiplying all these equalities side by side. So from the first one, this is 2. I have 2 here. 2 plus 1 is 3. 3 over 2. 3 over 2 squared. This is what I have here. Here I have 4 plus 3 cubed. 4 plus 3 cubed. And the next one, I want to see the pattern. I wrote 5 over 4 and the fourth. And then goes up to the last term will be n plus 1 over nn. The one previous one will be n over n minus 1, n minus 1. As we see, always the denominator will be the power, right? Denominator will be the power. And then since I multiply everything in the middle, that will be, I will get n because I have n items. And then from here, I have 2 squared. Here I have 3 over 2 cubed. Here I have 4 over 3, 4. 4 over 3, 4. But see, and this time the pattern is the nominator goes to the power, right? That's the nominator goes to the power. And the last one will be n plus 1 over n, and the power is n plus 1. And the one before will be n over n minus 1 over n. Now I need to tidy this up. I need to understand this. I need to write it down, find a way that this inequality will give me this inequality in some way. That's what I'm working out, step by step. So there are terms in here that cancels out, right? This is a 3 square here. There's a 3 here, but there's a cube here. So 3 square and a 3 square will be gone off, but I will have 3 left in here. Again, 4 cube and the 4 to the 4. 4 to the cube will cancel out, but I will have 1 left, 4 here, right? So what I'm having, so 2 here, 2 square here, square, and this one of them will be canceled out, but I still have 1 over 2 here. So this is what it is, 1/2. From here, I have 1/3. From here, 1/4. And then if I keep looking at the pattern, then I will have this one will be cancel out that one, but I will have n, the last term will be n plus 1 over n. And if I, here, everything will be gone. There's n minus 1 over to the n minus 1 will be gone. Only the n will be left. I hope this is clear. Right? This is the last term. And now this is e to the n, and similar to this pattern. So 2 squared, I will have 1/2 from here, 1/3 into the next, and so on. And the last one, n to the n will be gone, but I will have n because of this plus 1 here. N minus 1 will be canceling out previous one. I will have n plus 1 to the n plus 1 power, and I have only one n left because n to the n go on, n to the n go on, only the one n needs to be here. Okay, I want to understand what is there. So this is the power of n plus 1 power, and this is the n plus 1 to the n plus 1 power. There's nothing I can do for them, leave it like that. But what we have in the denominator, we have 2, 3, 4, up to the n minus 1 n. That is n minus 1 factorial. So that's n minus 1 factorial. And here, again, I have n minus 1 factorial. If I multiply everything by n minus 1, n factorial, and divide by e to the n, I will obtain exactly the inequality that I wanted to prove. That's all. So, so that's the logic. You start with the problem, you looked at what is given to you, what you need to assume. Is there any fact that needs to be used? You figure it out on your way, and you figure it out. So be brave. Even the questions looks like complex questions, be brave, please. Okay, that's all for this video. I hope it is useful for you.